Hi everyone. So before I start, maybe I can ask uh, who likes BMW car or for whom BMW car are their favorite cars? Just yeah? No. I just want to know like sense the mood of the audience. So no one likes BMW. Strange. Oh, okay, nice. So I'm in good care. Uh, so I can start now. What I'm going to talk about my experiences or our experiences when we were deploying an NLP or AI-based solution with industry manufacturing domain, and what I'm trying to tell you all what are the difficulties. Sorry. Oh, so I have to stand like this. Okay. This is difficult, but anyway. So yeah, some of the things which I would like to share, like what are the challenges we faced, and what are those pragmatic solutions we tried which helped in the real world. Okay, so that's where my focus would be. Some of these topics I would talk about, maybe little bit of vehicle development process. Maybe I can jump there. Before that, let me tell you who we are, like from where, which part of the organization in BMW I'm coming from. So I'm coming from the AI, artificial intelligence team, and what we do here, we apply AI use cases across this vehicle development process. So you have something in the research and development where we are trying to find out, okay, what kind of defects are occurring on the car when we are really in the earlier phases of the car development. So you can think about CAD and CAM simulation or requirement, how to make the door, does the door fit? Let's say there is a EU regulation that the frame of the car should sustain this much amount of force when it collide. How do you verify that, And then, of course, manufacturing, sales, after sales, chatbots. So we have also good experience with the chatbot within our team, procurement, and so on and so on. So if any of this topic is of interest to you, I would be open to talk after my presentation to you during the lunch. Now, maybe I can jump to my topic. So for a new car, how much year do you think it takes to really make the car? So think about any new model. What do you think? How much time would it take for us to make it? From ideation to the car on the road. Any guess in the audience?
3 years.
How much? You must have worked in automotive industry before. Okay. Yeah, so that's not it takes long to make a car, okay? And if it takes long, then you can also imagine the car is not made by one team. There are many teams, there are many processes, not one location, many plants across globe. So it's a very complex thing. But the beauty is at the end of the day, everything comes together. So that's how you see the car running on the road. And one of the challenges always, since it's a multi-year process, there is a lot of focus that, okay, this whole time frame is divided into multiple stages. The initial stages would be, if I simplify, it could be CAD and CAM model, simulations. You are designing some door on the simulation and you are trying to see, okay, does it fit the requirement or not? And you want to predict when the car can move to the second stage of the development. So the second stage of the development could be hardware prototyping. So where you are really making not the full car, but maybe part of the car. Maybe you are just making the door and testing, okay, everything is working fine, or maybe the seat. And you want to predict that when I can move into that stage. Because why you want to predict? Because maybe you have given some suppliers, maybe some company like who are the supplier of BMW, you want to give them some timeline that today is, let's say, October. Next April, I want this much quantity of screw from you. So you have to predict that. Why in April? Because you forecast in April, my car will move to the second stage. And this is a very difficult thing because what does it mean by second stage? You can only take the car into the second stage if there are, let's say, not so much of risk associated with the car. If there are some let's say if you do evaluation and the analysis is the car would cause damage to the people or the safety of pedestrian or the driver, then you can't move to the second stage. So you have to really predict, okay, after 6 months, how many issues I would have on this car? And that's a really difficult thing to do. But that's what we have to do here. So that's why you see there are concept phase, then there are audit. There are multiple audit because we are being tracked by regulation, also the customer safety. And then after 3 years or something, the car will go into production. That's when you order your car to BMW and the car will go in some plant, and from the plant it will come to you. So, yes. One of the things which we try to do, okay, hardware is very costly. So whenever we talk about hardware, things are already creating some cost. Let me give you an example. Imagine there are two parts which has to connect together to create a common part in the car. And then you realize the dimension of one part is 5 centimeter, other is 6 centimeter, then they will fit together. After 3 months, you realize this measurement was wrong. So the second part should also be the 6 centimeter. For a single part, this is a no-brainer. You can just increase the part by 1 centimeter, life is good. And maybe it will cost, let's say, €1 extra in making this 1 centimeter longer. But what we do, we also place order. Like I want 50,000 such part in the car. And 50,000 into €1 becomes €50,000. So the cost goes exponentially if we even do some small mistake in the hardware side. What we want to do, we want to predict before creating the hardware, at least, if not 100%, to the best we can, that what kind of error would come when we go to the hardware prototype. Because if we could do that, changing CAD and CAM simulation is much easier. It's only the software, right? Human process, not the hardware. How we can do that? So maybe I can come to this slide later. Some of the motivation, we want to identify our problem earlier. And another motivation is like, let's say you are making the new car, but every car is some kind of child of previous car, right? You have a model, and the second model is like enhancement of the first model. And that car, you would have sold it across the globe. And then you have data, what kind of the problem the customer actually faced. So it should be easy, right? That I have a previous car, previous model. I know what kind of problem the customer faced across the globe. I should not repeat that same mistake on the new car. This is also very difficult because these are handled by different departments, and maybe the engineers in R&D have no idea where the data of the dealers are stored. So when they are making the new car, they don't have an automatic way of knowing what are the mistakes or what are the defects we gather when the car was really running on the road. And this is a very difficult thing to do because from R&D to dealer, the separation is very large, and there would be, let's say, 20, 30 data sources in between that you can't just do some SQL join and try to find out. And that's where we are applying AI, that, okay, if we can connect all these data sources together around a part, and when we are making the new car, we can use the data of previous model and try to predict the defect which could occur in future on this new car. So that's our vision, that's our goal, what we were trying to do here. How we do that? So for example, let's say here what I'm showing you, let's say I have a car, then I would have that. Usually it happens when you make a new model, usually the door will come from some previous model, seat will come from some other concept, frame would come from some other previous model, and of course something is also new. For example, electric vehicle, because that's a completely new architecture. So of course there would be many new things on the new car, but also we will also reuse it. And in this particular example, if you see, We take those information from the previous car and then we start trying to do forecasting. That, okay, what kind of error I will get to this after 6 months? And even after 6 months, we will do another forecast. So this forecasting is very, very frequent. Initially, the forecasting is maybe even monthly, and then probably it will increase in the length. I hope I give you a fairly good idea about the complexity of the problem and what the problem is all about. And maybe now I would like to talk about some of the challenges in this thing. So first challenge is, what is the problem? So the problem is, if you see here, okay, what are the mistakes we made when we start this kind of problem? We try to predict the task itself. That, okay, let's make a model which could predict what are the top 10 problems on the new car, right? That's the one mistake which data scientists will end up making it. What we don't realize that we have to assist engineers in making the decision. So we don't want to make the decision by ourselves, but we want to assist those people. Because those engineers, when I say engineer, I mean mechanical engineer here, who are very trained, very qualified people. They want to take the decision, like, what is the problem? What is the complexity of the problem? And we want to help them with this AI. Why they can't do that now? Because they have no way of accessing different data from different sources. So they have to really email 100 people and try to find that answer. Second is how the data was generated. So personally, this point, when I started the project, I didn't even thought about that. And I burned my finger 3 months down the line, because when you see the data in a large organization, you have, let's say, one S3 bucket usually, or maybe some other data sources, and that's how you see that data as a single source. What we don't realize, that data was not created as a single data sources. Maybe it's a combination of 100 more data sets behind the scene. Until we understand that process, we can't create a good AI algorithm. Let me give you one example, very practical example. Some of our development happens across the country. Some in Regensburg or Germany, some in US, Mexico. And what people usually do in the plant have their own application. So when somebody in Germany find the problem, okay, they will write in German, this is the problem, blah, 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 blah. And then they will translate that text and append below it. And then they will send it to US colleagues. They are trying to help the US colleague, actually, so that they can read the English. And so they are doing a good intent. And these are different text fields in their source system. So you can imagine 10 different text boxes. So one is German, one is English. It is to help them. But when these data sources are combined, all these text fields are concatenated as a single text field. And now all kind of wonders will happen, because as a data scientist, you treat that text box as a single text box. You don't realize that there will be multiple languages. You don't have a fixed boundary where the language will change. You even don't know if I should take the whole text or part of it. And these are some of the practical challenges comes when we don't know how this data is being generated. So that's the second challenge. Model and metric. I think many of you are good data scientists, so I don't want to talk about metrics. Let's take F1 score, right? If I create an application, a model, and I say, hey, this application has 94 F1 score, what does it even mean? The challenge with us is our users are not like any general user. They are very good technical engineers. And when you quote them that, hey, I have a very good AI model with 94 F1 score, and that model doesn't work in real life. What you are doing is the expectation management does not meet. So next time, 94 F1 score becomes bad in their mind. So can you have a F1 score of above 94? That's very hard. And okay, I mean, F1 score of 94 you can have with data overfitting and all. I'm not talking about that. Even if you have F1 score of 94. So this expectation management have to be really, really important thing, because once you fail, your whole project might fail. Even if you have whole application, maybe your user are not willing to use the application. So gone opportunity. And of course, if I don't know what's wrong with boxes, and if it is really generating any business value. So you have a very good application, everything running fine, CI/CD, all perfect, but does it really have a business? Does it really creating any value to the application? Some of the data challenges, you can have multiple type of data. Some, what here is, if a very good engineer is writing the ticket versus a dealer is writing the ticket, even if they are using the same language, let's say German, it's a different kind of language if you see from the data science perspective. The distribution is different. A dealer would use some normal terms like engine, car, and engineers in the plant, they would use specific term for that part of the car. So you can't treat these different data sources as a German language. If you combine them, that may not work. You have all kind of spelling mistakes as usual, because imagine the car is moving in the assembly plant and you see the error, you have to really type it. Sometimes you don't have much time in creating the ticket. You write the ticket so that you can focus on the next car. And sometimes, okay, you can also find, thank you, advice, that's the actual number, nice to meet you, let's catch up. This kind of data also is there in the ticket. The challenge is we don't know where these things will come in the text field. So how can we separate that? So how did we deploy the first MVP? These are the different areas which we tried. The challenge was where to focus first. Because you have a limited budget, limited capacity, limited timeline, and within this timeline, you have to produce something which really works to a certain extent so that you can convince some, let's say, our management or the user that, hey, this thing had opportunities. So you have to really, you can't just focus, you can't just concentrate on all the part and try to make it best. You have to really focus where it matters the most. This is just one example how we created the first algorithm. This is a very high level. Unfortunately, I can't go in more detail here. But here, what I'm trying to show you, how we are combining two data sources here. So one data source is audit. The car is in the plant. You are checking if the door is closing fine or not. You take the car in a room where you do the rainfall testing and then try to see whether some water is going inside the car or not. And second data set is more qualified data set where very good engineers are writing ticket for on a very, let's say, holistic way. 5 minutes? Oh, okay. And so I will try to be faster here. What we do, how much label data we have? Probably 0.0023%. So that's also nothing. We don't have any label data. But still, we have to make our application useful. What we did, we said, okay, we have even, let's say, very limited data sources. Maybe that data sources is 0.1%. Maybe it's not talking about the whole data source, all kind of problem. We tried to understand within this 1% which is connecting across the data source, can we understand some business logic to that? So one of the business logic is that when you create a ticket, it's most of the time copy pasting, right? You take a template, you clone it like Jira ticket, and you try to fill it. Sometimes you don't fill it accurately. So maybe there is a field which is for filling the part of the car. The part of the car is door, let's say, or seat. And then there is a field for describing the problem. It could be you clone the ticket, the part is wheel, but you are writing about the seat. Now if you create an ML model, using that as a categorical field, you think this is a seat, but the problem is talking about, let's say, wheel, or vice versa. How do I know which one is correct, where it is not correct? And then one thing is like how these engineers are doing it. So what they do, they take the part and they try to really see, okay, if they in the text you are really talking about the seat or not. And that comes to them very naturally, and we try to use certain business logic to create a metric from 0 to 100. Of course, we have F1 score, we have all the coefficient, but we can't rely on them. So we have to create something which mimic the business, the users which mimic that. So that's how we took many multiple logic like that, and we created a score between 0 to 100. Is it perfect? No, it's not perfect. Does it work in real life? Yes, it works. So it's like a negotiation, like how far you should go and how far you should not go. So it's a balance of, let's say, standard metrics versus business metrics. And then when you create a function where you understand what is similar in this concept, then we try to use this function to deploy or to apply on that part of the data which is not labeled. So that's why you see all the red circle where there's no connection. And once you reach the second stage, you have more understanding what is a similarity means in your data set. And then you can also combine these two, you can merge these two data sources together. That's one way to start when you really don't have a label data in your data sets. Our application look much better than this, but unfortunately I was not allowed to show you our real application, so please bear with me. I'm going to share with you maybe within 2-3 minutes if I have, what are the non-scientific or pragmatic approaches which we did on the application which helped a lot. We added this text field to our application, and we didn't sell anything to the user. We just wanted to see, okay, what the user do with this text field. After some time, a user wrote, this real problem really occurred on the model in which he was doing sub-development. So he used this text field to convey his feeling about the problem, and he also explained more thing about this problem, which was not in the ticket. And this is a validation to us that, okay, we are hitting the right target. So we are really finding the problem which is occurring on the car. This is a no-brainer. Of course, you can use your feedback. If we predict wrong, we provide our user to decline the result, that, hey, this is not good. So that's okay. That was no-brainer. The third thing was, we to the extent possible, we tell the user on what basis we are taking this decision. Are we taking this decision only on the text field? Are we taking the decision combination of text field with some error codes? Are we taking decision on some other features, let's say? This is a very hard problem to find out on what basis the decision was really made from the model perspective also. But to the extent it was possible, we tried to do that. What happens, because these engineers are really good and they really know the car, unless until you tell them, they don't believe your result. So they will not use the application. They really want to know how did you come, on what basis you are saying this problem or similar. Unless until, otherwise there is no chance of them even using the application. And the last one, which is more funny for me, was one of the engineers came to me and said, hey, I can't see all the data in the application. I really want to see all the data. So far, our understanding was like, okay, we take the data, we clean the data, we pre-process it, there is some missing value, we reject those data set, and we are making the prediction. I wanted to see, okay, this prediction is right or wrong. That was our intention of getting feedback. But those engineers said, no, we want to see all the problem landscape. We want to know where the data got rejected. They really wanted to track the data movement across our pipeline, which is very, then it's, in the pipeline, you have to really add those features to log everything. So for example, if we are rejecting data because some is non-German languages, because our first application can only support German language, then we go English and other, we really have to tell them why we are rejecting that application. The fourth one became a crucial point because when we added this fourth feature, we saw engagement going very high. So they really started trusting our application that there is no magic behind the scene. It's really a scientific process. It works, we can trust that. Yeah, this was very counterintuitive, but yeah, that's the case. I know I'm running out of time. So data understanding, yes, we need to understand. Just understanding column, how many columns you have is not enough. You have to understand who created the data, what process created the data. Explainability, if you are in a manufacturing or some large organization, you have to really put your effort on that. You have to really explain why your model is making that prediction. Limitation of AI, that's really important. AI is not magic. That we have to communicate very clearly. If expectation does not meet, then you forget about it. But if you are really able to communicate that, they also understand it's an iterative process, and they will help you actually how to improve the application. Yes, maybe I can skip fourth and fifth. If you see ML models is the fifth point, because that's how important it is. You really have to create a baseline, get the feedback, and then go on the complex models. Just one last slide, promise. We also learned a lot during, this is not just from my team, like me, there are also various teams at BMW. I think yesterday there was a presentation from Volkswagen, if I'm not wrong. So we are also creating an AI platform within BMW where you have all this governance topic. Ethics is very important. Should we do this application or not? Should we really apply AI in this or not? Because we are constantly monitored by regulatories. And CI/CD, training pipeline, these are, if every data scientist start creating their own CI/CD, forget about it. So there are many components we can reuse, and that's what I'm showing you. And question answer, I hope it was useful to you all.